In a Delaware courtroom, a company that historically never manufactured a single chip filed a legal demand for the total physical destruction of advanced hardware. The targets of this order were highly customized server processor cores known as Oryon, acquired by Qualcomm through its $1.4 billion purchase of the startup Nuvia. It is a stark legal paradox. A firm strictly dedicated to licensing intellectual property holds the leverage to force a global manufacturing titan to physically destroy its own silicon. The source of this authority is a neutral architectural blueprint that governs nearly all mobile hardware and a critical share of the modern data center market. This map illustrates the scale of Arm's reach, with 99% of global mobile infrastructure executing code through their proprietary instruction set. This dependency now extends beyond consumer electronics. Hyperscale artificial intelligence data centers operated by Amazon, Google, and Microsoft are structurally dependent on this same architecture. This creates a systemic vulnerability, tying the functionality of global data routing back to an unassuming business park in Cambridge. The technical foundation for this reach was established in the early 1980s as a survival mechanism born from engineering constraints that favored efficiency over raw performance. In 1981, a small British engineering team at Acorn Computers was tasked with building hardware for the BBC Computer Literacy Project under severe financial restrictions. Operating on a fraction of the budget available to its rivals, Acorn could not afford the high-density ceramic shielding standard in commercial processors. They had to use cheap plastic packaging instead. At the time, Intel's complex instruction set computing philosophy dominated the industry. These chips relied on hundreds of thousands of transistors that generated intense heat, making thick ceramic packaging a physical requirement. This comparison shows Acorn's minimalist solution. Using reduced instruction set computing, the ARM1 utilized roughly 25,000 transistors, designed to run cold enough for plastic packaging. During testing, the power lines were accidentally unplugged, yet the chip kept executing instructions, running entirely on microscopic leakage current. This forced thermal efficiency became the technical blueprint for the battery-powered mobile revolution 3 decades later. When ARM eventually spun off as an independent entity, it made the atypical operational decision to function purely as an intellectual property entity. It would never manufacture physical silicon itself. Under their architecture license agreements, manufacturers paid upfront fees, followed by a flat 1 to 2% royalty on every finished unit sold. Competing tech giants willingly surrendered control of their hardware roadmaps to a third party because ARM strictly maintained its status as a neutral provider. The company promised never to directly compete with its own clients. This neutrality allowed a licensing firm to embed its logic into the core product lines of nearly every major hardware corporation on Earth. In 2020, NVIDIA launched a $40 billion bid to acquire ARM, threatening to end this long-standing industry truce. This flowchart illustrates a supply chain vulnerability called vertical foreclosure. If a hardware manufacturer takes control of the instruction set at the base node, they gain the ability to restrict the flow of resources to rival companies. The United States Federal Trade Commission intervened, utilizing a rare 4-0 administrative vote to successfully block the acquisition. Regulators recognized that ARM's independence was a structural necessity for maintaining competition across the semiconductor sector. Only a few years after the federal government protected its independence, ARM chose to abandon that neutrality. Reversing its original operating strategy, ARM engineered its own physical 136-core server CPU, manufactured on TSMC's premium 3-nanometer process node. The shift is driven by a change in economics. Pure intellectual property royalties offer high profit margins, but selling finished server components captures significantly higher absolute dollar returns per unit. This recontextualizes the litigation against Qualcomm. The legal demand to destroy millions of dollars in custom Nuvia processors removes advanced competitor silicon from the board as ARM enters the physical market. By sacrificing its role as a neutral architecture provider to directly compete against the cloud giants, ARM has permanently shattered the trust that made it the foundation of modern computing.